Guys, I think we can start now. While the others joining, I would like to introduce for you really interesting guest today. We have Marcin Ruta. He's actually an expert about the arc flash, about electrical safety things. So he's really doing amazing work about webinars, about life lessons, about consulting other companies and organizations, how they can save the employees from electrocution, and arc flash is his main topic. So, hello, Marcin. Once again, thank you so much for joining us today, and we're really happy to have you.
Yeah, thank you very much, Alessia, and I'm very happy that you put this all together and invite me to this to your podcast so we can have this interview and I can share a bit of knowledge with everyone else. Thank you very
Yeah,
much.
yeah, that's really great. And I think it's actually a very important point about the arc flash because it's really underestimated and quite frequently missed by safety professionals as well. So, just for people who actually have never witnessed the arc flash, how would you describe the sheer force of an arc flash event without relying to some statistics? And because it's really I would say outstanding how it looked like, right? So how would
Yeah.
you?
Well, the easiest way is to show it instead
Okay.
of explaining. But on the other hand, what I can say is like generally arc flash is an abnormal arc electrical arc situation, and also
Yeah.
it's important to say what it is and what it's not. Those are two
Yeah.
things.
Okay. Let's dive into that one
So
as well.
yeah, so from what it is generally electric arc that create the plasma channel, and then we have a lot of heat, and the heat
Okay.
is a problem because it's very hot, and very hot means something up to 5,000 to 19,000 degrees, which is way too much for our skin. Yeah, and that's why it is a problem. However, there is also a lot of situation when we have an abnormal arc or switching arcs or small arcing. So, for example, if you pull out the cable out of your socket, you also see some sparks, yeah, inside. But this is unwanted situation. We don't like it, but it is designed to be contained, and this is not
Mhm.
something we call arc flash. It's not really a problem. Also, there is some we can call it also as well that when the electric arc has more than 1.2 calories or has enough energy to cause second degree burn, then it starts to be a problem. And that's simplest definition of what arc flash might be. Is it AC, DC? Doesn't matter. Yeah, it's just the energy problem that might cause the burns to human skin.
Okay. But it looks really impressive. It looks like a fireworks, right? And it's really when I saw some videos, especially if it's really high voltage equipment, I think people all around maybe 10, 20 meters, any of them can be actually injured and gets really involved into the accident because it looks really outstanding.
Yeah, and it's better not to see it. That's the
Yeah,
point. If
absolutely. This
someone
is
saw
something
it
what you never want to
public,
have, right?
yeah. If someone saw it live, let me shut down one thing because something is annoying me here. So if we witness the situation, but actually the accident, that's not good. It's nice when you can witness something like this in type testing, equipment testing, some show-off situation when some manufacturers are doing this sometimes.
Okay.
That's good. If you will see this really live in your situation, that's not generally it's not good point. And I can tell like it's like generally it is because it's something like different. That's why the problem is a bit. So we talk about electrical hazards, and this is arc flash specifically. That's what we talk today. But we have to
Yeah.
keep in mind that electrical hazards are much wider areas. We have electric shock, and electric shock is much worse than anything else. Much more people die from it, and also
Yeah.
because it's invisible almost. So once you test, once you find out that there is a shock potential, then you already touch something and probably you might die. With arc flash, it's a bit different because you can actually see this. That's why it's a spectacular physical event because you see it and it's like, okay, I can see there is an explosion, there is a sound, there is a lot of molten metal around. Probably someone thinks about welding. That might be
Mm.
good relation, Just welding is very, very well controlled situation, so
Okay.
process. And this is totally uncontrolled situation when we talk about arc flash.
Yeah, okay. Thank you. Thank you for those details. And it's a good examples actually which you gave in about the difference between the arc flash and other electrical hazards as well, and comparing with welding as well. During my safety career, I still actually, I would say lots of people missing this during their risk assessments and during some design stages. If we talk about the electrical equipment, electrical panels, or working with these things. So, what would you say could still is the biggest misconception which people still have about an arc flash hazard? Why people still missing it so frequently? Maybe I think by people we need to split people into the different categories because it's as well relevant to health and safety personnel as well, maintenance personnel, and also electricians, right?
Yeah. So so there might be different misconceptions from different point of angle of view, and I can say that the reason why people sometimes skip it or miss it is because it's not that frequent even. But the problem is that it's this typical safety topic that is not that frequent, but when it happens, it's catastrophic in the outcome. So we try to protect ourselves. But if something happens 1 times 5 year, or nothing happens for 10 years, and then you have multiple accidents, and then nothing happens for next 10 or 15 years.
Mm-hmm.
And that's why sometimes people tend to skip it. But if I can say from safety perspective, from EHS or safety specialist perspective, this is sometimes skipped because safety people are not feeling confident in electrical safety. There is even very often in big organizations there is something called like subject matter expert in electrical safety, so dedicated person with electrical background for electrical safety only, which is also a concept in US and not that common in Europe, because in Europe it was more related with you are the head of engineering in electrical or head of electrical installation, and safety is yours somehow. So
Okay.
it's like different approach. But so this is from safety perspective, I would say, and the misconception is that it's not. I would say other way. The biggest misconception that this is only for electricians. The electrical hazards are not only for electrical people. There's a lot of work around, like automation, logistics, construction business. Those are not electrical people, but they are also exposed to electrical hazards. And this is something good to remember, that amount of accidents with electricians is actually smaller by percentage than amount of accidents with people that are not non-electrical, because they don't know what the hazards. Then from engineering perspective, it's strange because the arc flash as a hazard itself is nothing new. Like this exists since the electricity exists, so it's nothing new. We have bunch of this is even discussion I had yesterday. There is a bunch of standards from engineering perspective how to build switch gears. There are internal arc classification, arc rating panels, things like this that we already have, and we are building things against it from long time already, like 20 years or more. And but on the other hand, like everyone ignore it from safety perspective, from procedures, which is weird. I don't know
So, do you
actually.
think it can be still connected to the skills and knowledge as I can get from your response?
It could be because I see that if you are in electrical safety with arc flash project that I do, you need to know a bit more how to installation works, how we build electrical panels, how we do maintenance, how we operate. Also, we need to understand a bit from safety perspective procedures, so the legislation and everything, how we, for example, write electrical safety plans, how we operate, why we operate like this, what is legally required, what are the PPE selection, and also how to engineer it out, which are
Yeah.
sometimes a bit further topic than just building low voltage switchgear, for example. And I have a feeling that it's because of this. This is very niche specialization in something like this that you really have to dive into it. You need to know, have something from electrical engineering, from power system studies, from safety procedures, and also from organization. Probably kind of interdisciplinary type of education that you have to get at some point. Which I never get. I have to learn to answer your not answered question, not asked question. So this is from my perspective. But there's also one misconception of what I can say, that even you said this on the very beginning, that from logical perspective, people think that the higher the voltage, the higher the hazards, which is
absolutely.
valid for the shock hazard, for example, for electromagnetic field and so on. But from arc flash perspective, from physics perspective, it works like this. But from the practical perspective, how we build the installation, it's not always like this. Sometimes you might have a low voltage installation that have very, very high arc flash energy, and medium voltage installation that is actually not that bad. It's actually safer to switch something on medium voltage than go to low voltage. And I was like today on installation like this, that actually design of the medium voltage substation was so weird and strange, so confined, that when they say me how they do it, they said that you don't switch the transformer standing next to it, because that's how it was designed, oil transformer. So they actually switch it on while it's de-energized, and then go to 110 or 150 kV station to energize the full branch, full circuit. So they are not standing there, which is just because of the design of the old panel like this, old substation. So from my perspective, like low voltage doesn't mean low hazard or low risk. This sometimes is surprise for people, but that's there are some unlogical situations sometimes, and that's one of those. And also that there is one misconception that PPU will solve all the problems, because there are situations where you cannot match PPU. The energy is so high that even if you have PPU, no, it will not help you at all.
Yeah, we will get to this point in a minute.
Yeah.
I just want as well to thank you, because I was not actually aware about this kind of different direction sometimes about how it works, and that it's not always specifically depends or increasing the risk or the hazards based on the voltage. So for me as well, this is something new. What maybe I need to dive deeper to upgrade my knowledge. Thank you so much for this.
If I can make
Actually, what I
It's not that it doesn't depend. It's just sometimes there are more factors than just voltage that affects our. So because of this, it's that's why it's sometimes not logical, not something easy to predict.
Okay. But what I actually like about the modern trends about this, and the arc flash as well, that such companies like big brands, very reliable suppliers like Eaton, Schneider Electric, they're actually doing very, very nice as well video learning sessions, where they describe how it works, how the arc flash happens, and as well what people can do, what equipment they need to use. And it's really, they are free and they are really widely available. And it's really amazing how they sharing as well their knowledge and experience. So I think people should use this kind of sources more and more, just for upgrading their skills and knowledge, because it's really very reliable source of information. And as well, it really works to have a look what they're sharing sometimes on their websites and YouTube channels. So I would highly recommend to other people who are looking for some materials to check those sources as well. And if we're back to the PP, as you just started to touch this question, so for sure, personal protective equipment is very important when we talk about the electrical safety and electric shock. And for arc flash, it looks a bit different than the usual design for electrical life works. And as well, it looks like kind of a cosmonaut costume, right? So it's very maybe I would say it's quite uncomfortable, and as well it's still the last line of defense, right? So how to balance between equipping people with maximum protection without making this gears so cumbersome that actually it can decrease their liability to work and to work safely actually.
So this is multi-layer answer. So first thing first, aside of the different sources, I can comment to what you said before the question. There are a lot of sources. If I have to recommend something, then there are a lot of nice books written some time ago, but The physics is the same everywhere, and there are some guides happening now. Unfortunately, some guidelines are multiplying some errors that have been done long time ago. So once you read 10, 20, 30, 40, 50, probably you start to see that some things are copy-paste and they are probably not okay. If someone want to find a good source, I would say there's Electrical Power Research Institute in US that makes a lot of testing, and they did a lot of tests. So there's like big reports, and you can NFPA, of course, and IEEE Explore and IEEE papers are very useful, generally speaking, and also all the IEC and IEC, IEEE, and Senelec in Europe. If we talk the standard, they are very useful as a first source, and then the guidelines, everything else. Going back to the PPE, this is generally the first step is when you do anything, when we want to do something, we would like to calculate the arc energy or estimate it. Once we know the estimated value, then we can select PPE. Now, the problem is that I said it like this, it's like calculate and PPE, but in fact, that's not the goal. The goal is to have a safe environment for work.
Yeah.
So if you have something like 30 calories, 50 calories, 60 calories, or even 80, then just jumping to buying PPE, aside that it's financially probably not the best, but just to jump to the PPE, there are multiple levels, and the reason that I said this should not be done, because NFPA has a very interesting concept, which is called hierarchy of controls. There is similar concept in ISO guidelines as well, that there are 7 layers, 7 or 6, 7. There is elimination, substitution, engineering controls, awareness,
administrative controls and PPE. Yeah.
And PPE is at the bottom, at the end. And it's not that it doesn't work. It's just it's probably not the most effective on the hazard itself. So the fact that this, and it also has a one extra layer. So if you think about it, if we can eliminate something, then we should eliminate it. If we can reduce the energy to the bottom level, why not? Very often it's easy to do. It's not that something you have to throw a lot of money into the switchgear or something. You can do sometimes very simple things to improve it. And at the end, there is also a human factor in it, because sometimes the installation is built in the way that it doesn't forgive any mistakes, which is not good, because it's also saying a bit more that we have to do maintenance, we have to do operation. That's what this thing is for. We have to do it safe. If you do maintenance because you have some equipment failures, you do operation, generally we should build installation a bit more in a way that they will forgive a bit of mistakes. That's one thing. The second thing is that just selecting PPE will not solve the problem. It's like, sometimes like you say, we just tick the box, there is a hazard, here's your PPE, goodbye, enjoy.
Yeah.
And I would say it's not the best way, because people feel that something is not okay. If you give them this 40, 75, 100, 140 calories, because that's what exists on market, they really feel that something is odd and something is probably not okay, because why I should wear this thing just to do the switching? How dangerous this thing is.
Yeah.
And I understand, because I talk with them and it's like, yeah, it's like, and this is one side when something is very dangerous and you got the PP, because that's how it was selected, not just randomly, but we know it's 120 calories. Someone bought a 140 calorie suit from, there's one company doing this, or let's say we don't play with marketing, and then they are buying this, and then it's like tick the box, it's okay. But in fact, if you are the electrician doing this, I would not say that you feel comfortable wearing this. Aside of the thermal effect and having comfort, like today is relatively probably hot, and here already in Poland is 20 something degrees. Already you will start sweating a lot, and it's not comfortable from thermal perspective. But on the other hand, sometimes there is that's what we discussed before from safety perspective. So safety generally areas, people say, yeah, you have to wear the suit to open the panel. And people say, yeah, why? There is nothing really dangerous behind the door. Why I have to wear? And because you don't want to specify from 1,000 panels that you have to wear it for, I don't know, 600, because no one calculated anything. So they said, yeah, you have to wear it all the time. And they're like, yeah, but what? So then on the other side of the spectrum, people start to doubt that it makes sense. So if you just jump into something like this, generally that's how it ends up on site. That people generally like, yeah, they will generally pretend that they are using this. Eventually, they will stop using this. If someone is not looking, no one will wear it. And that's the problem, the layer of the problem that I have when we hit some site and I have to say, okay, why you have this suit? And no one actually can explain. It's pretty much like high level order in the company that we have to wear it, just because someone said like this.
Okay.
When we explain why, the people say, okay, here, and here, you actually have to wear it. And here is okay, you don't have to wear something like this. You can wear, like, adjust the PPE because we do a lot of things to reduce it. And then I would say most people, they accept and they say, yeah, okay, that makes sense for them. And this is the PPE situation I have. And of course, there's this is big area. That PPE are different. There's different manufacturers, but also they are manufacturers in at least three different ways. There are 2 different tests. Actually, there are more tests than 1 or 2. But as in Europe, there is a box test. In US, there was very popular open arc test. They are both the same ISE standards. So this is already complicating, but also even in an FPA, there are 2 tables for selecting PPE, which people very often mix. And technically, this is an error. It's not like huge error that you can make. And so there are a lot of things like this. And then there are all local-oriented situation where sometimes you have to adjust it a bit for country-specific requirements, like hot climate, like Middle East, when there is very hot. Maybe you will try to buy something which is a bit more easy to wear when it's very hot, like 30, 40, 50, 50 maybe not, but 45 degrees. So you try to have something which actually works, and you can wear it longer than 15 minutes before you start to sweat a lot. And if you are on the north of Norway, when there is minus 20, you can layer up a lot of things because the heat is like those different spectrums of PPE requirements, to be honest. And in one case it's easier, and the other case it might not be that easy to add, like adding more PPE doesn't always solve the problem.
Yeah, exactly.
It has to make different one.
And I like how you framed it, that it's not just about the PP, people, and just to build the solution, right? People still need to do the maintenance, service, maybe retrofitting or replacement and repairs, right? So, and this is where I think people and companies, overall organizations, when they sell the product or design the product, this is where lots of people are missing the important thing, that you not just supply the equipment. You sometimes forget that even your teams later on need to do the service with this equipment, or some other people need to work with this equipment, operate, maintain, repair, replace, etc. And safety must be a critical element and considered through all the design stage. Because if you installed something what is, I would say, was not the best solution based on the design, it still meet the needs of the customer to run the facility, maybe, right? But as far as there will be the moment come to make the service or maintenance, there could be some critical issues about that, about access, about egress, about safety devices, about engineering protection, and lots of other things, right? So I would say no one should always never rely just for the PPE only, or even start with PPE. So the standard approach as well, I think, on overall safety systems, they emphasize people to start with elimination, with substitutions, with engineering controls, right? So, and this is where should be the main focus. So we need to prevent, we need to think about the design more, and we need to try avoid this kind of things to happen, rather than just try to protect the people from the impact and injuries of these situations. If we go to the next question, and I think now it's time to cover some more technical aspects, right? So if we talk about the typical current protection, like circuit breakers, or how actually it affects the arc flash.
In simple way, If it detects the electrical arc current, it should affect it in a way that depends how the settings are done. You can increase the time or decrease the time, so it makes it worse or better. But if it is detecting properly. Now the overcurrent protection is like the 5051 NC, so ON as well, for protection function in low voltage breaker, but also MCCB breaker, the compact breakers, air breakers, the big one, the miniature breakers as well. So different devices, but the concept is the same. It's called the same. So, and also overcurrent protection are the medium voltage relays, high voltage relays. They have also the same function. From engineering perspective, just having something not necessarily mean that you tick the box and we are okay. Generally, if we have, assume we detect the arc flash current, yeah, we detect arc flash properly, and we have a different protections. The faster the protection, the less energy we have, because this is a time axis. And the longer it trips, then the more energy we have. And the problem behind it is that there is a concept called protection grading or selectivity, depends on the countries. That means that we would like to switch off something as close as possible to the place of fault. Yeah, which makes a logical decision because you would like to trip the motor, not the whole panel with 20 motors.
Yeah.
We don't want to trip one panel. We don't want to. We want to trip one panel, not the full low voltage switchgear, the main one, with 50 feeders, and shut down the half of the factory, for example, and so on and so on. So it's like the cascading effect. The problem behind it, that from my experience from the studies that we do, this is not often done correctly. So a lot of situations are. This goes both ways. Sometimes they are not selective and things are not detected properly, so we have very high energies. And sometimes things are not selective, but they are overprotecting. And actually, we have improper operation that might disconnect the whole site of half of the factory, but actually it's so fast, unnecessarily fast, that it's safer from our perspective, which is
Okay.
probably weird, but those are the conclusions that we have from the projects. And from overcurrent protection, this is one of the solutions that we do as, for example, if you do calculations and we do modeling and we have digital twins to do it because that's the easiest way and the fastest way, we will try to model the characteristics of the fuses, breakers, relays, and so on, just to know how they trip, how they react, and then try to influence it. But you have to keep in mind that from selectivity perspective, we would like to keep adding the time separation, so make it longer, because we would like to those split the times. Like we need to have 200 milliseconds here, 300 milliseconds somewhere here between the devices. So we hit certain level at some point that you cannot go above. But on the other hand, from our perspective, we would like to be as fast as possible, which is, those are two things that you need to
Yeah.
join together, and then have to make some compromise sometimes. That's why I said, like, it's not possible to actually trip as fast as possible. There are some solutions for it, but in most of the cases, it is some kind of compromise. And also that's something we talked about at the very beginning. It is a holistic approach, because if we cannot solve things with the protection, we might solve with something with the procedures. If the procedures are like weird, then maybe we have to do something with different engineering solutions, not the protection itself. Maybe
Yeah, like
PPE
you
is
need
the answer
to
at
have
some
different
point.
layers of protection, right? So you need
Yeah.
to capture and ensure that you have a different options. If one failed or one is not effective, or you don't need the most effective one, or you can't afford it, so you still have another barriers, right?
Yeah, and you can go with this as far as you want, but I would say as fast as is reasonable possible, because
Yeah.
if you start to assume that something doesn't work, then you end up overprotecting everyone. So there is a logical limit or engineering limit somewhere, because at some point you will get information like, yeah, but why this? I have this discussion yesterday again. Why this breaker should not react? We said it's maintained, so that's why the maintenance plans are important. We have a procedures. Everything is checked, works normally. Nothing happened with it. It's fine. Yeah, it should work. but that's why the maintenance is important as well. So you need to know that this thing will work, because if it doesn't, then we have to take the next one above, and the next one above might not be that fast. Actually, might not detect anything at all. I said, yeah, I don't know, like I'm waiting 2 minutes for you to do something, and it happens sometimes. We have a fault location. I have fault recordings that it takes sometimes not seconds but minutes for things to trip, which is weird.
Yeah. Okay. Guys, I started to see some questions as well in the chat. I would prefer if we can maybe answer them in the end of the session as well. If there are any other questions, please feel free to start asking them in the comments, and for sure we will spend some time for answering those.
Yeah.
So just back to still continue the topic about the technical devices, right? So have ever the client asked you something like, "Oh, if I buy an air-rated switchgear, does it solve all my problems?"
Yes, last week, for example. Arc rating depends how we understand arc rating, but I'll explain it. So if we have an arc rated switchgear, generally this is a passive. So there are two names actually for it. There is internal arc classification for medium voltage, based on IEC standards 62271 something like this. So it means for the medium voltage, and there is also technical report, which is for the low voltage, and if I remember correctly, it's called arc resistant switchgear. Both of those things are based on passive safety, which means that if the internal arc happens inside the panel, it should stay inside the panel. You should not hurt anyone outside. We can call it 30 centimeters outside, because if you see slow motion tests, it's not that nothing happens outside. But if you stay 30 centimeters outside and has something which is non-flammable, like the cotton, more or less, you should be okay. However, this is a passive protection for normal operation. So if I do infrared scanning, and so I open the panel and I play with it, or I have to do, I don't know, power quality measurements, I have to connect or something, then you don't have R rating anymore, because there is a lot of there's a lot of assumption behind. That's how it works, because you have to close the doors, have every covers in place. Otherwise, because this is like the physical, mechanical reinforcement of the panel. And by the way, there are a lot of new updates to the standards around arc mitigation.
Actually, I wanted to talk about this.
Yeah. So generally, there's a lot of IEC is doing a lot of work to bring up one completely new standard. There is the low voltage one, 61641, I think it's, for the low voltage arc resistant, is getting into more like guideline now as a technical specification. And this will be, I think it's already, something was done already 2-3 years ago. Something is getting updated this year and the next years. But we get more standards that we can use. Also for the information itself.
If we continue this discussion about the standards, so as I can see, currently all these technical standards and specifications, they are, I would say, expanding, and they're moving from just the passive protection, which integrated during design, right, to active, where we talk about more about the sensors and fast-acting devices that detect the arc flash and actually prevents the further damage. So how are the new technologies like arc flash relays, temperature sensors, predictive maintenance, or even remote switching affecting the arc flash hazard?
So positively, that's what I can say. So there is good thing that we getting more and more solutions on the market that are tested or are getting in, because we have more ideas how to solve it. Sometimes it's also because of the costs, so it's getting cheaper at the same time, or easier to access in different countries as well, in different continents. The topic is that the fun thing is that it's not new, because a lot of solutions exist for the last 20 years. It's just the standards, I would say, are catching up on this. They are standardized now, the naming, the convention, some approach, and so on. But in fact, Generally, I think the electrical safety starts to getting a bit more momentum in Europe. It's not new again, but it's arc flash especially, but also other things are getting a bit more momentum, more focus, and manufacturers and producers are getting after it because they are mostly in those committees. So if you talk about some names about the committees, they are mostly people out of companies that are trying to implement some solutions and standardize it so everyone has the same approach or standardized approach to something, because we all compete on the market, at the end. So it's better when it's a bit more standardized. It's easier for everyone. So we get now standardized naming and convention for active mitigation and some steps on it and levels. But I've seen this discussion some 2-3 days ago actually, and there are things which I'm not really happy with, I would say, or the way how it's because there is a tendency. I don't know how it's your experience, but I have a feeling that, like for example, I have a arc-rated switchgear. Tick the box. Arc flash is done. Yeah. And in fact, it's not, but it's or if it is, it's only one switchgear out of 200 panels in your place. But like, there is one word. And the same is with the PPE. I have an arc-rated PPE. Tick the box. And when you ask, how did you select those PPE? They're like, yeah, they are arc-rated. I said, yeah, but it has to be something rated, like 8 calories, maybe 12, maybe 40, 50. I don't know. What's your hazard level? They're like, okay, it's against arc. I said, but arc can be small or big. How do you know? And the same is with the other, with the technology. But I think this is a little bit different because it's rated when you design something. It's better maybe to have reinforced panel. But this is around switch gears mostly. Like the big main switch gears. So, but still there are a lot of MCCs, small panel boards, switch boards, distribution boards, which are like 160 to 150 amp, and they will be not really included in it. At least as far as I know, they are not really. Typically, they are not included in something like this. But they are also a problem. And
but it's, I think, still connected to the skills and knowledge, right? The competency of people, their awareness about how it all works.
Yeah, the first thing you need to know that this exists. That's the first thing. Yeah, so someone has to know that those kind of solutions exist, those kind of standards exist. I can use it and I can specify something. I don't know. Maybe I'm not that positive on a lot on things, but generally, as far as I see how it works for a moment, unless, for example, I work with someone like the customer and we explain them and say, okay, this is what you really have to do: install arc flash detection in this panel, has to trip this, this, and this, and that's what it will make, and that's how we will reduce the energy. I don't know, like this is the ideal world, but we said do it. There is a tender or order, whatever. There is few proposals, maybe. There are some companies that will try to build it. Also, someone has to install it later or implement it into their solution and understand what they do and test it. And each of those phases generally is prone to errors. And we kind of look, when we work with someone, we look after it. But the problem is that if you just say, I want to have an arc flash protection in the panel, a lot of suppliers will understand it a different way. Someone will say, I have an arc-rated switchgear because that's what they sell. That's what they have. If someone doesn't have arc flash mitigation, like active mitigation, like detector sensors, probably will not propose you this. If someone doesn't have arc flash quencher, probably will never mention that this thing exists. That's why the standards are useful, because they will bring everything in. So at least we know, okay, this is something I can choose from. And that's supposed to exist. So this is my problem. Maybe not my problem, but the customers we work with, that they are sometimes hearing first time certain solutions say you can do this, and they're like, oh, okay, we did never, but we have some companies doing the design, and they never said that we can do it. We said, yeah, because it's very specific solution that probably you have to know that exists. And someone is not aware, then he will just tell you that, yeah, I have no idea what this means. So that's interesting area, I would say. It's
So it seems like the standards now shifting from more generic approach to more details and support of the customers, right? So now more details about approaches, about what options are might be in place for a specific type of protection, right? So which could be helpful for customers.
Yeah. And I can tell you that different customers have different approach, because someone has engineering.
They have different needs as well, right? A different design solution.
Yeah. So it depends. You said skills and knowledge. That's what it is, because it also exists at certain sites. You have 5 engineers, you have 50 engineers, you have very experienced electrical guys, and that's very different discussion that we can do comparing to someone who just rent the facility or who just have something but has 2 electricians, for example.
Yeah.
There's a different. We can complicate something, but sometimes it's not. There is no reason to do it.
Okay, thank you for sharing your as well opinion about these updates and overall trend on the market, and as well about the, I would say, governance support about the standards. This is really helpful. If any facility manager is listening us right now and maybe realize that actually their arc flash labels 5 years out of date, or they were based on the very old standards and technical suggestions or design. So what are the first maybe 3 steps they should take tomorrow morning to start take care and updates about the arc flash protection, or whatever is might be your advice in this area?
So the first advice is to get your numbers. So just to first have identified the hazard. So once you know what you have at your site, you can do something against it, and then probably you save some money on it, because if we know that we have 100 panels or 1,000 panels and only, I don't know, 10% out of it has bigger issues, then you spend less money on it, yeah, because you know you can plan it properly. So first thing is know your numbers. The second thing is whatever you already done yourself, then you can also implement process a bit. So it's not like one-time job. It's something that should live a bit. So whatever you, for example, you have a facility, you have your factory, you did calculation in 2021. Now it's out of date because it's 5 years later. Typically they are 5 years, but sometimes they are 3. So 5 years is gone, you have to redo it. Yeah. And I can tell you, like, the worst thing that can happen is that your electrical manager is gone. So we hit the site and we ask, okay, what's new? No one knows. So to keep the skills inside, I would say it very depends on the person approach. But if you have a big engineering department, keep the skills inside and try to keep updating these things. Maybe with you some specialists locally that you have or globally, but try to keep updating this whenever you have a change in your installation. All the ARCTA studies, power system study, are valid for the time that they've been done. And whenever you change something, we should update this. It doesn't matter if this is arc flash or circulate or protection. Something is changing, we have to update it, check it. Is it okay? Yes, for example, or not. We have to update the labels, update PPE maybe, or something else. So it's better to do it like as a continuous process. It can be very simple process.
You always need to keep an eye, right, to stay updated.
Yeah. So I would say this is the simplest advice I can give, because there's a lot of advices I can have, but the simplest one will be this: know your numbers and keep updating the numbers. Most of the time for me, it's like 95-99% is with some external experts, but like me, but with external experts that will do this for you. But try not to wait to the very end of those 5 years, because sometimes it's easier to just do small update after 3 months, after 1 year, after 6 months, or every month actually, because we have people like this as well, the companies.
Yeah, because it's usually it makes lots of sense for approach, I think, because lots of companies, especially if we talk about safety professionals or any kind of upgrades about the safety devices, it always comes to the point about the budget, right? And if you wait too long and you need to update the whole your system, then it's very, I mean, it's reducing the chances that you will get the budgeting as well, right? It will be harder to justify why it's still all of those outdated and now we need to invest lots of money into that. So if you keep an eye on your equipment, if you keep an eye on the standards, on the regular updates, on the any changes about your capacity within the facility, as well as your needs, you always can stay in a, I would say, sensible and reasonable approach about it, right? So that might be helpful as well for continuously keeping the things up to date before waiting too long and spending too much money at one time.
Yeah. I can say one more thing that came to my mind now, because that's what we actually do ourselves. Also think if you would like to keep the skills, because depends on the size of the facility and the amount of people we have. There is a tendency that if you wait 5 years, there is a big chance that once you don't get financing. That's what you said. Is it capex or opex? Budget is also a
Yeah.
different story. But also there is a thing related with the missing things in it, because sometimes it gets to the point that it's so big update that it's almost like doing this from the scratch. And sometimes
Yeah.
it's faster to do it from the scratch, and that's not the point, because the point is to try to have. There was one third thing, sorry, that I have because I had a different thought. So that's one thing about this, about the reaching the point that no one really wants to start it again. But the third thing is that whenever you do some updates or changing and replacing the panels, you probably use some local people that will, the panel builders, local electricians, and so on. And I would suggest try to find yourself an expert company, because that's what we do, that was working with you in the early phase, on the design phase. So if you plan to modernize something like the substation, switchgear, and you do it, and then you say, okay, Marcin, can you update the Arclash study? This is not the best order. It should be the other way around, because if we do it before and we find some error or whatever, design things that are not okay, and we can simply change it. Every change on the paper is much, much, much cheaper than whatever you have to do in field later. If something is built, and we have projects like this, we build, it's not okay, but no one can change it, because no one will come back to the boss and say, yeah, we need 1 million extra because we actually did this other way around. And it's a simple thing, but yeah, we have to replace the panel, the whole substation, or the whole protection system. So this is one of the things. Think about this, that whatever calculation we would like to do, we try to do it before you take the purchase decision. And usually it's not that you have to add a lot of money, like maybe you add 5%, or sometimes it's just change of the equipment. It's not even cost related, that you can buy something different, spend the same amount of money, but to actually solve all of your problems.
Yeah, and upgrade the system,
Well
right?
spent money. And there's something in the bigger the project, and I think it works like this at the end, because we work like this. The bigger the site, it's better to have someone that is doing this for you, internally or externally, doesn't matter, that will do it on all the modernization project. Don't rely on the company that will supply you a substation, that will do your calculation, because just the companies are very good sometimes on building, delivering, starting up, commissioning, and they are very fast at doing this when they know the scope. When you start to hit them like, can you do this calculation for us? There's a protection. They're like, okay, I have no idea what you need, because they need a lot of data around and they don't have them. And when you have a consultant and model done, we already have the data. The only thing we need to know is like, okay, are you going to change this thing this year? Yes. So let's do the calculation before, and then you can keep ordering whatever you want. So it's like we do this before, typically keep this on your side, because I don't know why it exists like this. There's my conclusion that I have from years already, that if you order substation and you ask supplier to provide you arc flash labels, that's what people ask, but means arc flash calculation. Somehow the supplier thinks that if the label means 40 or 50 calories, this is their fault. and something is wrong with the equipment they supply. And in fact, it doesn't matter actually whatever they supply, because this is about the system around that is feeding this power into the substation, and something is not okay done a bit somewhere else. Not the equipment is okay, but it's like, you know what I mean? That it's like feeling that I provided you, the label says 50 calories, and everyone was expecting it would be safe. And we say, yeah, but it's not. The protection is a different substation, not in this one. So that's why you have a 50 calories. We have to just change the relay there. And like, okay. And when you have a supplier doing this, they are like afraid to say this. Like, you have a 50 calories. And they say, why? Because we bought the new substation from you, and you said it's 50 calories. We thought it would be solved. And actually, it's not. So this is weird. Yeah. Like,
Yeah.
this is my feeling. That it's better when you have someone internally that is doing this, because he doesn't care whatever substation you are bringing in.
Yeah, absolutely. You're right. Sometimes it's really makes sense just to stay, reasonable, right? Because in other case, if you will use suppliers or people who, for whom you just declined and then order with money, then they can just, act in a different manner. So it's always, let's say, if there is an option to do so, then for sure it must go from inside if you have competent people and skilled. Okay, and I have a last question for you. So, if there is one phrase or one rule you want every worker to replay in their head before they open an electrical panel, so what would it be?
If you don't have to, don't. There is no reason for it. If you have to, because you do your work, stay away from incoming side of the panel. I assume that no one knows the energy, and you just go to the panel. You don't have labels, because then otherwise means following the procedures, everything else. But the simple advice that I can tell that to mitigate the hazard of the very dangerous areas is there is a concept of line side, bus side, or load side, or you call it. It's just every panel has incoming cable coming in, or bus, which is always protected by something else upstream. And if you don't have to work in this location, don't play with it. Work wherever you have to, because there is sometimes a big surprise that this location will have something like 70 calories, but the place after the main protection, after the main breaker or whatever we have, it's like 7. And your PPU are properly rated or can withstand something or limit the injuries after the breaker. But if you get yourself this is like the transformer incoming side mostly. If you get yourself there, it's very possible that whatever you wear on yourself is not good enough. But this is like guessing without the rule of thumb. I would say that all incoming side of the panels are much more dangerous than after the protection, the main protection. So if someone doesn't have to do anything with it, don't open it, don't play with it, leave it alone.
Yeah, just stay safe, right? So stay away. Just don't do anything as far as there is no need in it. Yeah, what could be better advice than that? Absolutely. Okay, let's now maybe shift to our questions. So we have the first question from Alessandro from Brazil. So he's saying, considering human organizational performance principles, EHS tools often focus on human error rather than understanding the organizational context. Here in Brazil, we are undergoing a major regulatory shift with upcoming modernization of NR10, which strongly emphasizes risk management and shifting from reactive compliance to proactive engineering barriers. From your global experience, how can maintenance and safety leadership effectively collaborate to redesign tasks so that exposing live parts, such as removing panel covers, doesn't rely solely on the electrician's flawless behavior, but rather on the systemic defenses?
Okay. So generally speaking, what we get into slowly, different countries go different way, are the procedures, and trying to link this with the maintenance, and try to link this with the safety procedures, and try to link this with the engineering and design of the panel. For a moment, it's not done like this, which is a pity, but what I think will happen, and technically should happen, when we did something similar, but it's not exactly like this, For example, I did on the conference last year, we showed something I call PP task-based risk metrics. The problem with the risk metrics I found out is that they are very general. He said, is there electrical hazard? Yes. Follow procedures, wear PP, be careful, pretty much. And the
Yeah, but this
problem
is
behind it,
where maybe, sorry to interrupt you, because you've touched a very interesting point about the risk assessment, and this is where maybe I would like to add something from my side, because Alessandro was asking about an interesting approach, which actually I'm a fan of as well, human organizational performance, and this is where I would suggest to you not to stick to the generic risk assessment, but include the human error perspective as well. I think I
yeah,
had a
that's
different
what I mean.
session.
The thing is
Yeah,
that,
and you can incorporate and think, okay, where a person can fail. Okay, can
yeah,
he not use the PP? So how I can address it? Can he mismatch the, I don't know, the switchers, or can something be misaligned or disconnected or connected in the wrong way in the panel? Can he use, what we will do if he will use non-insulated tools? And all those errors where the person can fail, or complex procedures, or something confusing, or language barriers as well. If you work in a diverse environment, lots of things actually make sense, and lots of impact and effects to the safety level for people. So consider something like that from human organizational performance to integrate into your risk assessments, so you can as well improve the results and measures, not just rely on the PP or ticking the boxes, right? And just have a look at a different perspective from the person point of view, how they will do that, where they will fail. So, but
yeah,
that's
and I
my point.
agree with this. Yeah, I agree because it's more like listening to your people, what's happening, and looking on your installation and the procedures and everything around. This is a bit bigger, a bit topic than just
Yeah,
simple answer. But there was a very nice paper of Mike other on our conference, and the generally simple thing is that we go from lagging factors, human factors, to leading human factors. So we try to predict before something will happen, and find out that there is some indicators saying that probably someone is not well educated, doesn't have enough skills, and didn't have training, and probably this
yeah,
might lead to the accident. Of course, we might have a PPE, but okay, how we ensure that someone is wearing this? We have some substation entry training and so on. So there are a lot of things happening now, and it's very interesting shift. I would say more related with kind of acknowledging the reality. That's how it works. There are new installation, old installation, young people, old people in the work, and they will behave different. And I try to, because there was one my job as well, and I try to implement this in this task-based risk assessment that we started last year, and make it bigger also with the human factors. Because human factor and human error, I can add one thing into it, that I like to tend to call, there are human errors, and there is something like direct human error, when someone is actually touching, doing something wrong, and there are a lot of indirect errors, that people are designing things not correctly, they are not updating documentation, or someone is buying wrong PPE for me. I have no idea that I'm wearing something which should not be wear here, and not and just to understand, no one will check everything in their work. They will at some point believe that someone did the good job. No one has time to keep checking everything, because they don't have the data to do it. So this is very interesting area, and I agree with it. And the most important, I would say, in it, most practical for a moment, is linking the procedures and the condition of equipment with the maintenance. I would say this is very interesting area where we try to tackle it now, that which is coming in NFP 70B in US, that is obligatory maintenance plans for the electrical equipment, which is getting now 2 years already as a standard, when it's required to create a maintenance plan for electrical installation. So what I
yeah,
have to do in order to keep this thing in good shape, in operational shape, so it doesn't really, as the equipment doesn't start to be a problem for me, and doesn't increase the likelihood of things to happen. But however, in the risk assessment, this likelihood concept, everything else is tricky, because as far as I know, I checked the hazard levels, we calculate, we measure, we know pretty much. The likelihood, we kind of guess. And as we kind of guess, is tricky, because everyone will because I'm pretty sure I can take every risk assessment for anyone and make it safe, just playing with the likelihood. Because for everyone, someone's likelihood is low and for someone is high. And just playing with this, most of the time you can just make it workable. And this is something
Yeah.
which I have feeling this will fix it, because it will give some more numbers like maintenance is okay, not okay, or is low, medium, high. Did you service the breaker? No. Okay, sorry. So you cannot operate it, for example. So this is something I think will get more, because it's not in Europe actually, which is interesting. But it is in US now, and I think this is the same coming in Brazil, as far as I read a little bit about this. Long answer, sorry.
Yeah, that's fine because it really makes sense to mention all of those valuable points because you can't, again, as we discussed, rely on just one advice or one barrier, right? So for sure, engineering, as you said, is the best. And it was interesting how you've captured the risk assessment because I think it's really aligned with the human organizational performance approach. So thank you so much, Alessandro, for your question. Then we need to change the safety culture. There was a comment from Tassos. We need to change the safety culture. Consultants and design firms and clients are concerned that addressing operator safety in design stages will increase their liability. Safety by design must be overruling principle. Absolutely. I think it always must be kept in mind that people still need to work with this equipment, right? So, and this is sometimes the only point where you can capture the safety for operators or the safety for service teams. And it's sometimes really crucial to have this. So, yeah, Marcin, if you would like to add something about this, I'm sure people would.
I know what Tassos means by the liability, because generally the standardization and the new standards will bring this up, so we can have more visible reference. And when you have something like the standard, it's easier to reference something, say I want this solution. Okay, that's fine. We are not guessing, or maybe not guessing, but it's not based on someone's belief that this will solve the problem. It's one thing. The other thing, liability, and this is exactly what I hear, which I was, I don't care about this much because I'm not the manufacturer, but I hear this and I ask them if they are not afraid. Because if someone will say that this switchgear is safe because we provide ARC classification D, and I said, yeah, but it's safe to a certain point, and later probably it's not. So there is a lot of if you do something, and you know how it works. People think, okay, this is electrical safe by design, perfect, and you do something wrong because you think you can. You do something wrong, or you send a young guy there and say, yeah, just do it, and he will make a mistake because he was not trained, because you virtually think that you are covered, and then you find out in the hard way that you are not. And then probably someone will come back to those big companies and say, yeah, but you said this is arc safe or arc free or electrical safe. And they said, yeah, but there is like if you do this. And this is what I try to explain to people, that there are very nice features, but you still have to think.
Yeah,
And
absolutely.
we bring this up with my colleagues recently, because I used to work for different companies, that they also know that anyone who has a switchgear that failed or burned and has a contact and try to get money back from anyone, from insurance, you know that every time is your fault. Everyone will try to prove at some point that you make a mistake, you didn't make the maintenance, you didn't make something, and it's like, oh, should not be done this way. And eventually, this is the liability. So I would say solutions are nice, papers are nice, but we still have to rely on procedures, and we have to rely on what we know, and we measure or we calculate it. And we keep this in-house because eventually at the end we are responsible for it. So I will not
Yeah,
try to
so there is
rely.
no clear line, right? Because
Try not
still
to
both
tick the
parties
boxes.
are responsible for how they design and how they use the product, right? So you can't just always have a one door game where you just blame only one side. So it's the way how we cooperate, and that's kind of a partnership because end users still need to understand how to use the product, how what the hazards are, what's the skills of their personnel, and lots of other things, right?
Yeah,
As well about the liability, actually, it's an interesting point because I think unsafe design make the companies even more in trouble, getting them into trouble, because as far as it's completely unsafe, then you have even more problems, and it can get even to the really, really bad cases. I really have experience with one of the providers. I won't name the company, but some of the designs sometimes suggested and approved even by client or whatever, it can be such an unsafe that really severe accidents might happen. And then you back where? You back to supplier, right? And you're saying your design is not safe. How we should, like, we didn't consider some of the maybe points when we were ordering this, or the client was confirming the design, but now we are in trouble because your panels are not not serviceable. So how should we work with your panels or something like that?
That's
So,
what's your scope of work. That's what you ask for.
yeah,
And
yeah,
maybe there was a discussion in between, but there was some 10% extra cost and you didn't like to accept it. Sorry, for example. And sometimes it's like you start with someone, and if you know that you would like to use different features, then you know you have to change actually supplier to have it, which is impossible later to do. So there are a lot of, that's why I said, like, it's better to do those calculation things before and try to find out before that they say by design what you need. And
absolutely.
so you have, at least you hit proper direction, and later maybe you can modify or add something if you really have to. It depends how it works. Sometimes it works in stages and things like this. And so this is one of the thing. But I don't know. It's like because we focus a bit of, and this is like the bias thing with the panel builders and suppliers of the switchgears. They try to refer to what they have as a current offer, but there's plenty of installations which have been in late 60s, 70s, 80s, 90s. So they are
Yeah,
still there. They are still operating. They're 60 years old, and no one's like, yeah, it works. There is no life limitation for the electrical installation until it works, and no one will force someone to change it. It will just be there. I was on the installation today like this, and it's there. It's dangerous. By design, it's generally the worst thing that you can see, but operates. So far, it's okay, and it was okay by standards in 80s. And no one will force you to recertificate it today. So because it's not, you don't have to backward make the installation compatible, and that's it. Yeah, works
okay,
fine. Thank you, and that's it. Yeah. So I would
yeah,
say this is
you do
interesting
right.
but by design, it's something that I would say is missing a bit. That if you think how engineering companies works and how people start, I used to work like this as well. That when you hit the engineering R&D office, you are after the school, you are an engineer, you start designing things, but in fact, you don't have any experience in operation, maintenance, and so on. Maybe you will learn
Yeah,
from your colleagues, but you never have to be responsible for the installation, but you are designing the switchgears. And then you keep doing this for 10, 15, 20 years. And you probably learn over the years, but in fact, then you hit the site and someone says, yeah, but we have to do this, this, and this, and this every year, and this every month. And then you look, okay. Like I've seen a lot of weird designs that no one ever thought that people have to put the temporary earthing in the
okay.
panel, and they have no place to do it. They have to really think how to do it in different way.
Yeah, I would say design is something what both parts needs to consider, either the manufacturing companies, either as well the end user, right? Because they need to think how they will maintain, how they will service, how they will operate, how they will repair or replace any or do any kind of upgrades about this. So they need to think a bit more ahead, and ensure that they happy, or at least with some scope of the solution, right?
Yeah,
So not just blindly buy something and then start to ask questions. Oh, actually, we need as well to do the service. How we will do that? Oh, now it's not serviceable. Or oh, actually, we need to replace something, but it's not possible because it's one unit, right? So oh, what should we do now? So this kind of things must go from both perspectives. Okay, then a question from Mohammed Harris. Can current limiting circuit breakers play a role in reducing the incident energy?
Yes. The simple answer is yes. Yeah, they do. Also, the fuse are current limiting very often, and they also play the role. And and this was even tested by IEEE when they did the IEEE 1584 new model in 2018. So simple answer is yes. This is something that we like and we actively use. By the way, current limiting is also used in the cascading, so backup protection. If you would like to install much smaller, because it's in use for a long time. If you want to install 25 kiloamp breakers, because they are cheaper, but you have actually 35 kiloamp, and you install current limiting fuse or current limiting molded case circuit breaker, and you can drop down the short circuit down to the lower level. And current limiting is generally the solution for arc flash mitigation, but it might go too low, where you actually will not trip below something, which might be a problem. But this is, I would say, more like the medium voltage networks kind of problem for a moment than low voltage.
Okay. Then we have a question from Mohammed Siraj. Siraj, glad to have you here as well. So, electrical hazard don't bleed; they don't leave visible scars on the work site, and an arc flash is over the in milliseconds. Yet the consequence can be catastrophic. Why do you think electrical safety is consistently underestimated compared to other workplace hazards like falls or chemical exposure? Is it the invisibility of the electricity, or a culture problem, a training gap, or something deeper?
It's skills. That's something what I said on the very beginning, that it's treated in the way that safety, somehow, I don't know why, electrical safety and also explosion areas are like this. They are like very specialist areas. So from safety specialists, they like, this is your problem, you are the electricians, yeah? Handle it. We have a certification for a long time, so it's like handed over to us. We never handed over the money for doing this. But the problem is a little bit different, I would say, as well, because you have comparing on amount of people in your factory, and you have, like, say, 1,000 people, probably you have 10 electricians. And also the accidents are not that often, like tripping or something else. So if you look on the statistics, everything else, you'll find out, yeah, there's few people die in this country, or 20 people die in this country per year. So you can calculate, probably it's not going, like, I'm not saying it's work like this, but from statistical perspective, it's rather rare events, and it's good that they are rare. Yeah? And that's why sometimes people tend to think that you don't have to do anything into it, and they start to ignore it. And the problem behind it is that it's invisible, you don't see it, but you have to maintain the safety, you have to keep the safety, you have to maintain the safety. So there is a certain level of effort that we have to keep doing to keep it without accidents. If you just do something and you forget about it, probably after 1, 2, 3 years, you have an accident, because you just, like with the memory, you just forgot about this, and then something will kick in again. And so we have to keep doing something to keep this safe. And this is active effort. It's not like the passive thing that we can do. We did the training 1 times 5 years and then you're covered. You actually have to do maintenance, you have to do measurements, you have to keep checking things, and this is obligatory very often, just to keep the installation safe. And that's one very important thing. The second thing is, like, it's not that it's invisible, it's not in milliseconds. Arc flash can be in minutes, technically speaking, or maybe seconds, but minutes sometimes happen on high voltage. So it can be much longer. It can cause fires, building fires, damage, injuries, and so on to people. So it leaves also gives you a hint that something will happen. It's not that it's like out of blue, but it can be like this as well. Because if you drop the tool on purely new, you might have a new low voltage panel that came to your site. Someone forgot the key or whatever, wires, and you energize, and it's like done. And we have sites like this, unfortunately, that they are working, and then after some rebuild, someone forgot something, they have a hard start on the motor, and just someone, I don't know if I can show it properly, installed the cables on the C-steel section like this. So there was a motor start, it like cut the wires through it, and then caused the arc flash, then the field explosion. And it was 2 years old panel. So something which we call brand new in electrical work. And so generally speaking, I would not say it's not like this. Sometimes there is more action after the accident, which is unfortunate conclusion that someone has
Yeah,
to die
reactive
in
approach,
order to
right?
get the money for the rest, or has to be heavy injuries for someone to allocate the money. I would say it's a bit more regulation topic related. If someone will find it, but the fun thing, the regulations are existing. It's not that actually they are not. They are existing. We are required to do things. We are required to do risk assessment. We're required to do maintenance. Because it depends in each country how people look at it. Is it important or not? If someone sees it as a problem, then probably will try to solve it. But I would say it's more about the knowledge and explanation than other forcing. If your manager understands, yeah, if this thing fails, then we have a 2-3 weeks off, and you will lose a lot of money on it. If we have a fatality or heavy injury in this place, probably you have to stop it for next 2 weeks or 1 month for investigation and so on. And also, it's the cultural thing as well, but I think physics is the same everywhere. So the culture is like probably not related directly with it. I know what you mean probably in the background, but in fact, everyone understands that it's dangerous when they are electricians. They just violate the rules, but at the end, they understand what they are doing. And if someone said that he was surprised, it's like, yeah, then you should not be electricians at this point.
Yeah.
But it is something related with the skills, knowledge, and awareness, and we work on the awareness now today.
Yeah, absolutely. I think awareness actually is a critical part here. So, as well as the skills, but it comes with awareness maybe first, right? So you realize that you have a gap in the knowledge, or you need to as well involve some technical personnel. And for sure, you always need to maintain the same level with, as you recommended as well, regular checks and updates of your systems, of your electrical panels, of your devices. Keep an eye of your capacity or other things, so you still can continue to move forward the proper things in place, right? And this is the best advice I think which we can give about this. Okay, then Tassis as well, giving a comment. How many of the active arc flash protection devices offered by various vendors have been tested and verified? To my knowledge, independent tests will be performed later this year.
You mean because they are all tested and verified?
Yeah, I think they should be right
Uh,
because that's how the industry works.
you will not be able to sell it. And if you mean if they have been tested in the field and verified over the years, then if you find the list and you take probably 10 out of the list, they are like for last 20, 30 years on the market. This is not new. Yeah, the active protection is not new topic. This exists for last 20, 30 years. We have a company in Poland here that is doing this for a long time. And they went from very all the steps probably. And we have discussion like if you install the active detection, can it trip if I have a light, for example, the flashlight there, or if I take the phone, will it trip? No, in fact, it should not. And everything was tested a long time ago, and they have a lot of failures in the past as well. Everyone, so this is taken care already. And I would say if you, but what is counter logical maybe here, that top switchgear manufacturers are actually not top manufacturers for the active arc flash protection or passive active. Passive is with switchgear related, but the active is not necessarily related. They sometimes buy the companies to have the product portfolio and so on, and that's how it works with the very big companies. But those doing the protection systems and so on, there are a few big companies, but in fact, the rest are comparing to them, they are very small, but they are very highly specialized, and they have like typically 1, 2, 3 products. So this is the core business that they do, and they do it very well. So short answer is, as far as I know, yes, it's tested. Yes, it was proven. It's installed for last 20, 30 years in the panels, in the switch gears. But I know what you mean probably because there is a lot of new sensors kicking in. A lot of companies, new companies going back, now going into the market with the new solutions that they 2, 3 years ago, they never did something like this, and now they do. And the question is if this is okay or not. I cannot tell you. Typically with this business, unless it's price wise much cheaper, probably people will say no, we go with the very brands we know and they are proven. However, it's like it's hard to say because there are some new things like the what's the name for it? I just lost it now. You have the classical breakers that we have, like electromechanical and so on, but there are also not called digital breakers, but breakers based on the electronics, like for the DC systems, and they are kicking in now in the AC, which are super fast. And this is something new that I know it's happening now, but they are not widely adapted yet. So hard to say. I would say they are tested. Whatever you know from the top 10 names, it's tested for a long time.
So next one is from Kirill Godinot. Sorry, apologize if I pronounce it in the wrong way. Great presentation, Marcin and Alicia, and customer that have been exposed to an arc flash event with more or less impact are much more aware that beyond light sensors and arc flash relays, solutions including arc quenchers are the most effective to reduce incident energy by a factor of 10 typically, while ERMS, if when activated, would only reduce incident energy by a factor of 2 or maximum 3. Studies are great, but do not reduce incident energy, only provide indication on how much the exposure might be, and recommendation on mitigation human impact, but does not reduce property for nor business interruption impact.
So one note, Cyril, if you do arc flash studies, you also evaluate mitigation. So what you wrote, ERMS, energy reduction maintenance switch, if you talk about the arc quenchers, arc flash optic detection, or arc resistant switchgear, this is supposed to come as a decision out of the properly done arc flash study, because you evaluate what it is at this moment, and then you try to check, okay, if I install the arc quencher, what it will give me. If I do ERMS, and ERMS you can do on the medium voltage, also on low voltage and medium voltage as well. If I install something else, like the optic detection, and depends on the tripping zones, what it gives me. If I give zone selective interlock, what it gives me. So we try to predict first or calculate first what this solution will give me, and I can tell you also from the cost effective, because it's important for the customers, that okay, I can go with the arc quencher, because we do also projects like this, and whenever it makes sense. So that's why I say know your numbers. If you know that your numbers are not crazy high and we can limit it with only overcurrent protection, I would say it's nice if you have money for arc quencher, but it's no really reason to do it. Like if you don't have money, then there's even less reasons to do it. And we can spend money from quencher, because I don't know, maybe I can say it like, but from the cost perspective, it also goes with the magnitudes. Yeah, you can use overcurrent protection as a reference cost, and then you go with quencher, which will bring your cost also a few times more. So if I have a limited budget to do something, and we have not one but 20, 30 locations to solve, probably no one will, at my customers at least, they will probably not go with the 20, 30 quenchers on site, which are a great solution, by the way, but probably they will not do it because they don't have a budget for it, and they will not have budget for it for a long time. So in order to fix it, we can evaluate, can we change the settings? Can we install the maybe much cheaper arc flash detection systems? Maybe we can have a small modification with the protection relays. Maybe we can retrofit the breaker to a new one because they are old. Or maybe you can replace the full panel, but this is like crazy extreme situation. There are a lot of solutions that we can do. This is why I'm the consultant. I'm the engineering consultant to help people to decide. If they say, okay, we would like to eliminate completely the hazard. And we did on a few projects like this with the quenchers from different companies. And then we say, okay, we can install it here. And then we go below 1.2 because they are super fast, less than half cycle. And they will just, it's called arc quenchers device, but it goes like arc extinguishing. The arc extinguishing, it doesn't mean like the fire extinguisher. It means that it will just, I don't know if I should use that, like stop the arc flash or arc very fast when there is no arc, but three-phase short circuit, then we don't have the energy released in form of heat, and the rest we can trip later. So we can use something like this, but I like to go also with like the steps. If someone has a budget for it and is limited, then we have to solve it. If we cannot get, for example, below 40, maybe you have to do alpha detection. If we cannot get to the certain limited level, like below 8 or 4 calories, then maybe we can go with arc quencher. Maybe we can do some, but maybe it's not feasible because there is no space for adding this, and so on and so on. So, there is a situation, but this is related with the Tassos question before, which I'm checking now. There might be case, which I'm not sure, not fully aware, but about the type testing, that you install the arc quencher in the panel, and the supplier of the panel might tell you that you cannot do it because they are afraid about the type testing. Technically, it should not work like this, but I have a feeling that they might try to do it this way. So to prevent you from using the solution that is on the market, but it's not by the brand name A, but the company B, and you cannot use it. So you are kind of literally blocked unless you replace the whole switchgear. And suppliers of those systems, they are not manufacturing the switchgears. They cooperate with the switchgear manufacturers very often, but they sometimes don't have their own switchgear design, for example. So this is interesting area, but I would say realistically looking on the problems we have in field, if there is a budget and I can buy 1 quencher or 10 arc flash optic systems, then we buy 10 arc flash optic systems. Ideally, we will do it in the way that we buy 10 arc flash optic systems that can be extended with the quencher in future. And if someone has money in future, in 2-3 years, we add the quencher later. And this is probably
Yeah, like there's no one solution which actually fits everyone, right? So it still depends on your budget, on your capacity, on your needs as well, and your measures and other things, right? So that's why we still have all of those layers of the control measures, right? So
that's how I work.
Yeah, we still need to stay sensible as far as there is no, I would say, really like full freedom for the design and suppliers and all costs covered and all these kind of things. All companies would be like that, but again, sometimes it's not maybe completely necessary, right? So it still must be reasonable as far as it's required so far. Then Diego Castro, I invite you to get to know the switch safety anterior closure, which from the design eliminates the risk of accidental reconnection.
But it's after the event, yeah. So I know what you mean, but it doesn't solve anything for the accident itself. It just if something trips, then it will not close back again, which is maybe not on the low voltage, but in a lot of places it's adapted that you have to do something, reset it, for example, or so on. But this is just after. Yeah? It will not solve or change anything from the hazard level, at least during the event.
So
not someone to energize it back while I'm still there. At least if I understand your what you wrote correctly, but that's how I understand it.
Okay. Yeah. So this is where maybe as well people have some misunderstanding about how the things works from the engineering point of view, right? And that's where we sometimes need to be more precise and track and get our knowledge back on track or our expertise expanded, so we know how the trends are going, how specifically the equipment works, and what it does.
Well, I can say a few more things because. The first thing first is there is no one solution for everything. There are many different installations on the market, many different customers. They work in different ways. So I know there is we like to find one solution to fix everything, but probably there is no reason to do it. And we always have to look holistically. So the arc-rated switchgears are nice, but they are not covering all tasks we do, and will not be covering us every time or all the time. Internal classification on mini voltage is very useful as well. Most of the switch gears are adapted. There are a lot of things related with the hazard itself. So we try to reduce the hazard or influence the hazard level from the arc flash perspective. So we would like to have a lower arc flash energy. But sometimes we cannot do this, or there is technically limitation, budget limitation, doesn't matter. We cannot get into it. So maybe we can do something cheaper to, instead of playing with the hazard, maybe we can play with the likelihood. This will be visible in the risk assessment later. So we can make it less likely for things to happen, which, as I said, likelihood is something which is in soft areas, which it's not like, it's hard to engineer this out and give real numbers. Say this likelihood is like 79.3%. Yeah, so we always have like low, medium, high, whatever high means and whatever low means for someone. But still, there is something and this is design in my feeling area, engineering area design, which will open a lot of opportunities to do something for likelihood, for things to happen, but also trainings and onboarding process, on-site training and things like this. There is also things related with the procedures. So we have to write electrical safety programs, generally safety programs, do the training and certification and so on. But also we have a procedures how we work. And this is also interesting because it's likelihood, but also procedure might reduce the energy itself, but also you might keep people away. And there's a lot of work done and engineering solution to this called move people further away. So you have a remote switching. Sometimes remote switching means really remote switching from SCADA systems and so on, but sometimes you can have a local remote switching. And there's a lot of, and this is weird area because there is always solution that will solve one or two or three things at the same time. So you might reduce energy, lower likelihood in like a stupid thing, but it's not stupid solution, but stupid outcome of how that you have to do infrared scanning. Well, in Europe it's mandatory every year. In US it starts to be mandatory now. And of course you can open everything, remove the covers and keep doing scanning, but you also can install the sensors and forget about opening things. There are some legal side of writing reports out of it, but generally you just have a permanent monitoring. So you don't have to keep opening this panel, so people are not there. So you reduce the, not exposure, but the frequency of jobs or tasks that you have to do. The same thing you can do with the, infrared scanning. And you can also do, if you have to do absence of voltage test, part of the fire safety rules are part of the local tagout, which is part of the fire safety rules that you have to do absence of voltage test and after the switching off. So you also can have a permanent testers mounted, which you don't have to do anything. They work different way, but sometimes you can classically test it on the safe connectors, or you can just click and then check, evaluate, okay, there's no voltage, but this is not like the voltage indicator, it's really like the bit smarter device. And that's it. And also you eliminate one step, make it safer, cheaper, safer, faster even. So there are a lot of solution engineering is kicking in, and we figure out a lot of interesting things. I can tell you like most stupid thing I have in head for a long time. If someone will figure out something like the very thin aerosol that I can just put like the chemical suit on my face, which is like 1,000 calories per square centimeter, like that they do on the spaceships, then probably we will not stop talking. If it will be electrical isolated up to 100 kV, this will probably solve all the problems we have without solving any problems in the panel installation. Why not? So there are you don't know what will come in future, yeah. And we also look on some wireless energy transfers. I have no idea what kind of electromagnetic field will be as a hazard there. So try to look at this kind of thinking outside of box, but I would say thinking outside of your substation. So try to look a bit wider in your installation, because it's not about the only product related things. It's like you have a complete factory. The fact that you solve problem in one place, and it's great, yeah. But you still have 200 old panels, machine panels, and some other things, which brings very similar danger to people And the fact that we have brand new medium voltage substation is great, but it doesn't solve all the problems on your site.
Yeah,
Generally.
thank you so much for mentioning this as well, because for sure there are lots of measures, lots of differing things, and as well as technical as other type of solutions, right? How we can protect people from the arc flash, and as well, one of the comments from Free Anton was we always take focus for MOC with process safety, for hazmat, for arc flash as well. So for sure there are lots of things how we capture that, and what I really like about current world that actually the products and suppliers and organizations, they move forward with with the progress. So more and more engineering solutions are available, including really smart ones, and I hope that it will go in that direction even furthermore, so we can really keep going in the right options for people's safety without putting them at risk, without considering that they do something what actually is not based on their skills or knowledge or wherever it might happen for a reason, for sure. But yeah, overall, I think that it's a good trend.
Yeah, I think so. The same. It's just evolving. In past, we know the hazard, but we didn't know that it's like super
Yeah.
important. Now we are focused more on the human safety as well, not only equipment safety. So we look from different angle, and it's okay. I don't know what will come in future, like human performance factors getting in as well. So this is just like in the background is just to make things safer for us. Yeah, so we can go back home every day. That's it. Nothing
Yeah,
special.
that's the purpose, right? So people need to go back to their families, friends, pets, relatives, and that's the main purpose of.
Sometimes we might overcomplicate things, and I would say that sometimes engineering solutions are getting as a rescue because they can simplify it back, and this goes both ways. So I also have like there is this KISS complex context that we keep it stupid simple. I like to do it things this way. So if we can solve something and it doesn't affect, so there is no mental effort for people to think about it, that's the best way. Which is also
Yeah.
getting into human factors, because if you have to constantly think if you are doing correct way, and then there's a lot of I know like how it works is like people in maintenance in factories and electricians, they have a lot of things, procedures, permit to works, everything else to do, and it's mentally heavy. So you have to keep thinking if you're doing correct and so on. You are responsible for someone's life or safety, and that's, I would say, a lot already. Arcflash is one of the things out of the award, so we have to try to solve it, and that's why I think people try to solve it with the product, so they tick the box, it's done, and we forget about it. In fact, you cannot forget about this, but we try to make it as simple as possible, and sometimes making things simple make it safer, because you
Yeah,
don't have to
absolutely.
think, you intuitively understand what's happening. And I would say if I have to call something like this, we try to do it this way.
Yeah, I really like that you mentioned this because it's really important. Sometimes we just overcomplicate, and as well, some smart solutions start to come to the market where actually it's getting more simple for people to use it or to install the product, and it's as well make them safer. So people have less space where they can make the mistake or any other impacts related to their based on their skills, knowledge, or any external factors as well. That's really great how you frame it about the simple options for safer work. That's really a good one. Thank you.
Yeah, you're welcome.
Okay. So I don't think we have any other questions. I'm really glad to have you today. Thank you so much for joining. I'm I'm sure that all our audience got lots of insights and lots of good advices from you today. Much appreciated for you for sharing your experience and your expertise. Even myself, I've learned something new today. Much appreciated for this. Thanks everyone for joining us today, and wish everyone to have a good weekend.
Yeah, thank you very much, and have a nice weekend too. Yeah, stay safe.
Yeah, stay safe and take care. Okay, bye.